Welcome back. Today, we're diving deep into the mechanics of ingesting data into Snowflake. We will focus specifically on the critical roles of stages and file formats, the structural backbone that allows Snowflake to read and interpret your data correctly. To get data into Snowflake, we don't just push it into a table, we follow a specific mechanical flow. First, understand that all data files must reside in a stage before loading. Think of the stage as a loading dock. Whether it's inside Snowflake or in your own cloud bucket, the data must sit there first. Next, we have the file format. Snowflake doesn't guess your file structure, you explicitly define it using a file format object. This tells the system how to handle delimiters, compression, and headers. Finally, we execute the load, moving data from that stage, interpreted by that file format, into your target table. Here is the visual flow of ingestion. On the left, we have your raw data files. These must first land in the stage storage, represented by the blue box. This is your staging area. Below it in yellow is the file format object. Notice how it feeds into the loading process. It acts as the instruction manual for reading the files. Finally, the copy into command executes the move, reading from the stage using the file format definition to populate the green target table on the right. Let's look closer at file formats. Instead of typing parsing rules every time you load data, you create a named file format object. This is where you handle the specifics. For CSV, you define your field delimiters, whether to skip the header row, and how to handle empty strings versus SQL null. For semi-structured data like JSON or Parquet, Snowflake can automatically handle compression and parsing, but you still define specific options here. By creating this object once, you ensure consistency across all your data loads. You simply reference my CSV format later rather than rewriting the rules. This diagram treats the file format like a class definition. The base file format class holds properties available to various types. We see two specific implementations here. The CSV format sets the type to CSV and defines specific behaviors like skipping the first header row. The JSON format sets the type to JSON and might use options like stripping the outer array. This visualizes how a single Snowflake object encapsulates all the complex configuration needed to parse different file types correctly. Now let's discuss where the files live, starting with internal stages. These are fully managed by Snowflake. We have three types. First, the user stage, denoted by tilde, is your personal scratchpad. Second, the table stage, denoted by percentage, is tied directly to a specific table, useful if files only matter to that one table. Finally, the named stage is the most flexible. It's a standalone object you create, secure, and share among users for various data loads. To get files here from your local machine, you use the put command, which automatically encrypts and uploads your data. This mind map breaks down the three types of internal stages. At the top is the user stage @tilde, your personal space. In the middle is the table stage @%, which is tightly coupled to a specific table structure. At the bottom is the named stage which is the production grade choice because it is a distinct object that you can grant permissions on, allowing multiple users and processes to collaborate on data loading. For production data lakes, you will likely use external stages. These point to storage you manage in AWS S3, Google Cloud, or Azure. The critical component here is the storage integration. Instead of hard-coding sensitive access keys into your scripts, you create a storage integration object that authorizes Snowflake to access your cloud bucket via IAM roles. When you run create stage, you reference this integration and the URL. This is secure, scalable, and lets you manage the data lifecycle entirely outside of Snowflake if needed. This sequence shows the secure handshake for external stages. The user initiates a request to the Snowflake stage. The stage doesn't store credentials, instead it calls the storage integration. The integration authenticates with the cloud provider like AWS or Azure using secure IAM roles, not static passwords. Once validated, the cloud provider grants access, allowing Snowflake to read the files directly from your bucket and stream the data back to you. A powerful feature you should implement on stages is the directory table. Think of this as a built-in catalog of everything currently sitting in your stage. By setting directory equals enable equals true, when creating the stage, you can query the stage as if it were a table to see file names, sizes, and timestamps. This is incredibly useful for processing unstructured data or building dynamic pipelines that need to know exactly what files are waiting to be loaded. You can even configure it to auto-refresh when new files land in your bucket. This entity relationship diagram illustrates the connection between a stage and its directory table. The stage entity on the bottom holds the connection details like URL and integration. It has a one-to-one relationship with a directory table. The directory table entity exposes file-level metadata attributes, relative path, size, and last modified, allowing you to query the stage contents using standard SQL. We arrive at the final mechanism, the copy into command. This is where the stage and file format converge. You instruct Snowflake to copy data into a specific table from a specific stage, applying the rules of your file format. This command is powerful. It can transform data on the fly, such as reordering columns or casting data types directly during the load. You can also use the validation mode parameter to simulate the load and check for errors without actually moving any data, ensuring your pipeline is robust before commit. This state diagram shows the execution flow of the copy into command. Starting with staged files, you can choose a path. If you use validation mode, you branch to validating, which produces an error report if issues exist. If you proceed with a standard load, you move to loading. Here, you can optionally pass through a transforming state to modify columns or types on the fly before the data finally settles into the target table.